Good afternoon. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to talk about today is foundations. Now, if you are in the field that I am in, known as civil engineering, when you get into geotechnical engineering or soil mechanics, you will discuss foundations or foundation engineering. Now, you have different types of foundations, like your piles, your caissons, to name a few. But basically, what a foundation does, it supports your structure. I'm going to share my screen and we're going to get into what a foundation is or a footing. First, let's talk about the footings because you have footings and foundations. Now, basically, the bottom part of a foundation is called the footing. Now, footings in construction are very critical as the footing basically distributes the load or the weight of the building evenly across the entire structure so it doesn't have any sinking. Now, a good footing will also prevent water and moisture from seeping into the foundation, which causes other damage such as cracks. Now, when we talk about footings, generally they're made of concrete, but you can even use other materials such as wood, brick, and stone. Now, the type of footing that you're going to use is going to depend on the type of soil and the size and weight of the building that you are going to construct. Now, what you have right here is a footing. That's what it looks like. It's a concrete footing. Now, generally, when we deal with footings, there are 4 different types of footings. So most building contractors will decide between the 4 types of footings in construction. Now, you're going to have individual footings, combined footings, strip footings, and wrap or mat foundations. Generally, when you talk about a mat foundation, generally, you're going to use that when you are constructing an abutment for a bridge. Now, again, the choice of the footing is going to depend on the soil, the load or weight of the building, and what type of build that you are doing or what type of methods of building that you are doing. Now, again, when we talk about the 4 types of footing, your individual footing is the most common type of footing because when we deal with small structures such as sheds and porches, that's where you're going to see them. Now, individual footings are also used for all 4 walls of the building if you have soft soil or you have a high water table. Then you look at combined footings. They're basically used when you have 2 or more foundation walls that are close together. They share the load. Now, combined footings are used when one of the foundation walls is much taller or longer than the others. Strip footings used to support a long foundation wall. The example would be a side of a house. They're also used to support load-bearing walls that run parallel to each other. And then you get into your mat or raft footing, and that's just one big concrete slab that supports the entire building, or again, if you're building a bridge, the abutment. Now, raft foundations are used when the soil is too weak to support individual footings or when the building is very large. Now, when are footings used? Well, footings are used in any type of building that has a foundation, and that includes commercial buildings, bridges, houses. Footings are also used for fences, decks, and other structures that are not attached to a building. Yet you can even use a footing or support when you are putting up let's say you're constructing an intersection and you have to put up signals. Well, you can use footings to support the base, or you use a footing to support the mast of a signal. And you know your signals are also cantilevers as well. Now, looking at this picture, you're looking at some foundations and footings. Now, how are footings built? Well, before you construct any structure, you have to build a footing. That's the first step. And that comes after excavation is complete. So when you build a footing, you have to dig a hole. And then once the hole is dug, the footing itself is now created. And the depth of the footing hole depends on the type of the soil and the size of the building that you plan on constructing. Now, when we deal with the hole, it must be deep enough so that the footing is below the freeze line, so the depth at which water in the ground freezes, and above any salt or loose soils. Now, once the hole is dug, the footing must be created. Now, this can be done by pouring concrete into the hole by using pre-made blocks of concrete, stone, or brick. A footing must be level and must extend past the edges of the hole so that it can support the weight of the building. Now, after the footing has been created, the foundation walls can be built. So basically, the footing walls are usually made of concrete, but they can also be made of, I just mentioned it, stone, brick, or even wood. Now, the walls must be strong enough to support the weight of the building, and it must be tall enough to reach above the ground so that the building is not in danger of collapsing. Now, again, when we deal with footings, we deal with a support system. Now, as I share my screen again, I'm going to get into the PowerPoint and show you types of footings and how they're actually done. Now, this is good information if you are a civil engineer major. Now, I'm combining both of the topics together. So I talked about footings, but before you even have a footing, you have to have some type of foundation as well. They both go hand in hand. Now, what you see here in PowerPoint number 2, that's a foundation. Now, again, foundation, it's a structure essentially consisting of 2 parts, namely the superstructure, which is above the plinth level, and the substructure, which is below the plinth level. Now, substructure is otherwise known as the foundation, and this forms the base of the structure. Generally, about 30% of the total construction cost is spent on the foundation. So basically, the soil on which the foundation rests is called the foundation soil. So what are the objections or the objectives of a foundation? Well, a foundation is provided for the following purposes. To number 1, distribute the total load coming on the structure on a larger area. To support the structures, to give enough stability to the structures against various distributing forces such as wind and rain, and to prepare a level surface for any concreting or masonry type of work. Now, when we deal with foundations, there are basically 2 main types of foundations. You have your deep foundations and your shallow foundation. Now, your shallow foundations, you see a lot of those, also known as a spread foundation. And then when we go back to footings, there are also spread footings. Now, types of shallow foundations are isolated footing or single footing or column footing, combined footing, and then you have your pile foundation and your pier foundations. And also, you have your friction pile and your load bearing pile. Now, under ream piles, it's a type of load bearing pile. As we get into foundations, what you have here, the shallow foundation or spread foundation, that's where you have the depth, it's less than equal to its width. Now, the isolated foundation or your single foundation, column footing, is when you have frame structures where several footings are to be constructed. You also have the adoption, or they can be adopted, and I'm talking about isolated foundations. Then the columns involved can be provided with any masonry or concrete foundation. Now, if masonry footing is provided, steps are given, and the foundation area is thus increased so that the stress developed at the base is within the limit. Now, in the case of a masonry foundation, the projection of each step must be 1/2 brick thick, and each step is made of 1 or 2 bricks put together. So basically, concrete can be molded to any shape, and hence a concrete footing may be a sloping one to provide sufficient spread. And here's an example of some concrete footings right here. It's like a reinforced concrete column footing, and this is a masonry footing. Looking at the foundations, this is a spread foundation. And we are talking about right now the isolated footings, your single footing, your column footing. There's your simple column footing, your simple wall footing, your sloped column footing, your stepped wall footing, and your stepped column footing. And again, foundations. This is what it looks like. This is your footing right here. This is your foundation right here. On top is a footing, and here's your column. You can see it right here, your concrete pad, which is essentially your footing, and then you have your steel beams. Your iron plate, basically your plate is going to have a column bolted to it, and then your I-beam, that is going to be a column. We get into this is a wall footing, which you generally have a spread foundation. Your wall footing could be used as a retaining wall. And what does a retaining wall do? It holds back the pressure of soil. Then we get into our combined footings. Again, I'm giving you this review so you can see the picture of what some of these footings look like. So as we get into combined footings, it's a footing basically adopted when the space between the two columns is so small that the foundation for individual columns will overlap. And when we deal with combined footings, they are proportioned in such a way that the center of gravity of the loads coincides with the center of gravity of the foundation. Hence, these footings have either a trapezoidal or rectangular shape. Now, again, on top of a foundation is your footing. Now, footings are structural members used to support columns and walls, and what they do, they transmit and distribute their loads to the soil in such a way that the load-bearing capacity of the soil is not exceeded. Also, excessive settlement, differential settlement, or rotation are prevented, and adequate safety against overturning and sliding is maintained. Now, if you have what we call differential settlements, it's basically when you want to drill down into soil, you want to hit the bedrock. And if you don't hit the bedrock, you may incur some differential settling. And what's going to happen? You're going to have a crack in the foundation, and you're going to have to utilize underpinning. Now, again, here's your combined footing. Here's your property line, and here's what the combined footings look like. Here's your column. Here's your footing. Now, also, something that we have too, and these are very popular, a pile foundation. Now, when we deal with piles, piles are a slender structural member consisting of steel and concrete. Again, a pile is a slender structural member consisting steel or concrete. You can even have timber piles. Now, it is installed in the ground to transfer the structural loads to soils at some significant depth below the base of the structure. Now, here's what you have. You have your piles. They drill them, they go into the ground, and then they cap it. These are your pile caps. And then you can put a footing on top to support this load. And here you go right here, the foundation. So you know exactly what I'm talking about. You can see the model of this house right here. This house has been set on piles. Again, pile caps, just like I mentioned before. They're thick slabs used to tie a group of piles together to support and transmit column loads to the piles. So you have your column. Here's your pile cap. Now, if you're doing bridges, you have a pier cap. Here are your piles. And this right here, this looking at it from the top view, these are your piles right here. And here's your column. And you can see how the piles work with supporting this truss structure. Also, we have a deep foundation. They consist of pile and pier foundations. This consists of carrying down through the soil a huge masonry cylinder, which may be supported by the sides of soil or may be supported on solid rock, hard stratum. You can see how this pile in the longitudinal section, this is a concrete pile. Now, let me tell you, when you're dealing with piles, piles deal with blow counts. So there's a hammer that hammers these piles in the ground at a certain depth. Piles must be inspected and tested to make sure that they're suitable to use for the construction of the building. Now, again, we deal with a pile foundation. That's an element of construction used as a foundation. So it may be driven in the ground vertically or with some inclination to transfer the load safely. When we have pile foundations, loads are supported in two different ways. So if the load is supported by the effect of friction between the soil and the pile skin, it is called a friction pile. Friction piles may be made of cast iron, cement, concrete, timber, soil, wrought iron, and composite materials. Now, if the load is supported by resting the pile on a very hard stratum, it is called a load-bearing pile. Load-bearing piles are steel, sheet piles, concrete piles, and timber piles. Piles may be cast in situ or precast, or they may be cased or uncased. And here's what the load-bearing pile looks like. You have your rock, you have your bearing, here's your pile, your cap, your load. Your load is coming down. If you were doing a diagram in statics, you're going to see that your force is always going down. You have your ground surface and you have a column. Now here's your friction pile. Well, Cohesive soils actually grip the side. That's where you get friction. Cohesive soils, you have sand, sand and clay. This is when you step into the muck, you try to pull your feet out and it pulls your shoe. That's that friction. Here's the load. Generally, you have sands and you have clays. Again, here's your load-bearing piles and your friction piles. You can see this is here's the ground reaction, firm soil, your in situ reinforced concrete pile, your penetrationable or penetrable soil, your performed timber pile, skin friction. This is your friction pile. Penetrable soil, your skin friction, penetrable soil, your in situ concrete or reinforced concrete pile. Now, what do they mean by reinforced concrete? Reinforced concrete is concrete that has been placed with rebar. Now, what the rebar does, it strengthens the concrete by adding some tension to the concrete. Now, again, types of piles. Concrete piles, you have cast in situ piles, which are concrete, cased in situ piles, uncased cast in situ piles, precast concrete piles. Then you have steel piles. See a lot of those out there, especially when they're putting in a bridge. They're generally, you can call them H piles, I piles, they're H piles. Then you also have your cylindrical piles and your tapered piles, timber piles, composite piles. Types of pile construction. You have your displacement piles. It causes the soil to be displaced radially as well as vertically as pipe shaft is driven or jacked into the ground. Then you have your non-placement piles, or we call them replacement piles. Now, in the case where you have the soil that's removed, the resulting hole filled with concrete or a precast concrete pile is dropped into the hole, and there's going to be grout that's going to be placed in the hole. And here's what you see in the examples here. Method of installation. And I just told you before, generally when they install piles, they use what we call a weight or drop hammer. That's the most commonly used method of the insertion of displacement piles. Then you have diesel hammers, most suitable to drive pile in non-cohesive granular soil. Then you have vibratory hammers, or a vibratory method of pile driving, which is very effective in driving piles through non-cohesive granular soil. Then there's the jacking method of installation. And this is what the drop hammer looks like when piles are being installed. In fact, the drop hammer method I see more commonly because I work out here with roads. So basically when they're putting up a bridge, a lot of the piles that I see are your cylindrical piles. And here's the pile driving rig. What that does, you have to have, when you're driving a pile, there needs to be something to support that pile so it's going to go in straight or incline. So they use a pile driving rig. It's a temporary support for the pile that's being driven. Then you have the jacking method of insertion. Jack piles are most commonly used in underpinning structures. Now, generally, when you underpin a structure, it's going to be a structure that could have failed or it has cracking. The Leaning Tower of Pisa, they use a lot of underpinning to make sure it doesn't fall. And the reason why they call it the Leaning Tower of Pisa is because it's actually leaning. Now, when we use the jack method, what happens is you excavate underneath the structure And then what happens after that, then you have basically, once you excavate beneath the structure, then you have the short lengths of a pile that are going to be inserted and jacked into the ground using the underside of the existing structure as a reaction, as you see it right here. And generally, if you have differential settling, that's exactly how underpinning is constructed. And that's it for this section on footings and foundations. If you like what I just presented, please comment, share, and subscribe. Now, if you're looking for more political and social content, check out my main channel, the 411 Talk Zone Radio Show channel. Now, once I record all of my videos, whether it be on the 411 Talk Zone Radio Show or the QCIS channel, I will upload both of those videos to my Twitter page. Now, for the QCIS channel, since it is an educational channel, I also load videos from the QCIS channel onto my LinkedIn page. And in the end, thank you for listening to the topic, footings and foundations, basic civil engineering, right here on the QCIS channel. On this channel, get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious day.